Question 19. Sketch the curve y equals x to the power of 4 minus 2x cubed plus 2 by first finding all stationary points, checking their nature and finding the points of inflection. Find the x coordinates of any stationary points by solving the equation y dash equals 0, where y dash represents the first derivative. Now it's given that y is equal to x to the power of 4 minus 2x cubed plus 2. So differentiating y with respect to x, we get y dash is equal to 4x cubed minus 6x squared. So we want to solve for x, 4x cubed minus 6x squared equals 0. Dividing all terms by 2 to simplify the equation somewhat, we get 2x cubed minus 3x squared equals 0. Factorising out x squared from both terms on the left-hand side, we get x squared times 2x minus 3 in brackets equals 0. Therefore, x is equal to 0 or 3 over 2. Next, we find the corresponding y coordinates of the stationary points we just found. So when x is equal to 0, substituting 0 into the original equation, we get y is equal to 2. And when x is equal to 3 over 2, we get y equals 5 over 16 or 0.3125 as a decimal. Next, we determine the nature of the stationary points, and for that we can use the second derivative y double dash. So differentiating the first derivative, and we found the first derivative up here, y dash is equal to 4x cubed minus 6x squared. So differentiating that another time or a second time with respect to x, we get y double dash is equal to 12x squared minus 12x. Now when x is equal to 0, the second derivative, y double dash, is also equal to 0. That means that the stationary point at the point where x equals 0 is a possible point of inflection. So it could be a horizontal inflection point. So when x is equal to 3 over 2, y double dash is equal to 9, which is positive. So around the point where x is equal to 3 over 2, the curve is concave up. Therefore, there's a minimum stationary point around the point where x is equal to 3 over 2. So finding points of inflection by solving the equation y double dash equals 0. Now from before we found y double dash, which was 12x squared minus 12x, and we're going to solve that equaling 0. We can divide all terms by 12, we get x squared minus x equals 0. Factorising out x from the left-hand side, we get x times x minus 1 in brackets equals 0. Therefore, x is equal to 0 or 1. Hence, we have possible points of inflection at x equals 0 or 1. We also need to find the y values at those points. So at x equals 0, y is equal to 2, which we found before. And at x is equal to 1, y is equal to 1. But we need to test these points of inflection, so to make sure that they are in fact points of inflection. And we can do that by checking for a sign change in the second derivative y double dash around those possible points of inflection. So we know when x is equal to 0, y double dash is equal to 0. When x is equal to 1, y double dash is equal to 0. But testing around those points, and I've chosen x equals -1, x equals 1 over 2, and x equals 2. At x equals -1, the value of y double dash is equal to 24, so the curve is concave up there. When x is equal to 1 over 2, y double dash is equal to -3, so it's concave down there. And when x is equal to 2, y double dash is equal to 24, so it's concave up there. So we have a sign change, positive, 0, negative, 0, positive. Hence, the point 0, 2 and 1, 1 are points of inflection, and the point 0, 2 is also a stationary point. Now we need to graph y equals x to the power of 4 minus 2x cubed plus 2. Now y is a polynomial with degree 4, so it's an even degree. Hence, y approaches infinity. In other words, y gets really large in the positive direction as x approaches either plus or minus infinity. So as we move further away from the origin, either to the right-hand side or to the left-hand side, the y values get larger on either side. So we should have two arrows at each end of this graph pointing upwards. And we know that also because the leading term, which is the x to the power of 4 term, is also positive. In other words, the coefficient multiplying x to the power of 4 is positive, which is why the two arrows on the endpoints here point upwards. If the leading term was negative, the graph would be the other way around. These arrows would be pointing downwards instead. So here is a sketch of the curve y equals x to the power of 4 minus 2x cubed plus 2. Draw the axes with a ruler. Try and make sure that the y-axis and the x-axis are perpendicular to each other. Clearly mark the origin, the x-axis and the y-axis, and I've marked in the 3 points that we found. So we have our horizontal point of inflection here at 0, 2, which is also the y-intercept. We have the other point of inflection at 1, 1, and we have the local minimum point at 1.5 or 3/2, 0.3125.